Okay, so today I'm going to give you an example of something that can be used to represent isotopes. So isotopes are atoms that are of the same element, but they differ in the number of neutrons, and so some of their physical properties, such as mass, are different. So to kind of represent two things that are the same element, I have two things that are both balls, but they have some different physical properties, such as different masses. So you can see the tennis ball and the baseball are pretty similar in size, but the color is definitely different. If we try to bounce them, they definitely have a different bounce to them. So there are some physical properties that are different about them, and they definitely have a different mass. So we're going to use these as an example of isotopes, and we're going to calculate the average atomic mass of our element ball. So average atomic mass is based on the mass of each of the atoms. So the mass of a tennis ball is 58.5 grams, and the mass of a baseball is 149.0 grams. So in order to get the average atomic mass, we first have to look at how many we have of each thing. So if we're talking about natural occurrence in my house, I have 3 tennis balls in each of these containers. So 3, 6, 9, 12, 15, 18, 21, and then I've got 2 loose ones. So I have 23 tennis balls. And baseballs, there are 6, 12, and then I have 1 loose one. So that's 13 baseballs. So when we look at natural occurrence, we have to add up those numbers and then divide each of these by that number. So 23 plus 13 is going to give me 36. So I want to take and divide this by 36 and this by 36. And you can kind of see that 13 divided by 36 is going to be roughly a third. So, but when we put it in the calculator, we get 0.361 for this one, and we get 0.639. So one way you can kind of check yourself if you've done the math right is that these two numbers together should equal 1, because that's basically saying 100% of what you have. And sure enough, if I add the two numbers together, I will get 1. So that tells me my natural occurrence. Then I want to take that number and multiply it by the mass of each. So I've got the 58.5 and the 149.0. And when I multiply this out, I get 37.4. And I get 53.8. And remember to pay attention to your significant figures. So I have 3 significant figures. This one I have 4 significant figures. So when I multiply these things out, I have to keep the 3 significant figures because we're using the one that has the least number of significant figures. Okay, so once I take the natural occurrence and I multiply it by the mass of that particular isotope, then to get my average atomic mass, I'm just going to add these two numbers together. So I get 91.2 grams, and that is going to be my average atomic mass